names. My name's Sam Trautwein. I'm one of the co-founders of Treachery and one of the people behind mach.exchange. Today's talk is called Trust, Treachery, and TEs. So privacy is something that gets a lot of people talk about privacy and like what it means for crypto. In blockchain today, anything you do on chain is happening in the open. This is pretty close to how the internet used to work 20 years ago, where HTTP was the standard for moving any form of data around, which meant anyone between you and the server could read the contents of a packet. Anyone on the same network as you could intercept packets and read their contents. This severely limited what you could actually use the internet for, because doing things like banking or even putting your social security number through a packet was very, very risky, because you're essentially trusting every person who touched the packet and every device on the same network as you. HTTPS was rolled out over the past, it's really only gained adoption in the past 15 years, but has completely changed how the internet works in terms of allowing things to happen that couldn't happen before, because now we can trust our connections between the clients and the servers. Once you have the ability to have encrypted communication between a client and the server, it became the amount of things we could use the internet for massively expanded. It massively just expanded the TAM of the internet. Online payments became possible, online banking, even just secure messaging. And what's cool with HTTPS is once privacy became an option, the amount of people using the non-private systems went way down, as you can see by the data on the screen. There's a saying that Andy Grove gets credit for, which is that in technology, whatever can be done will be done. Once you have systems that have a lot of upside and no downside, there's a degree of inevitability in terms of their adoption. So the road to privacy is something that gets a lot of discussion. There's a lot of different approaches, and all this is still pretty early stage. ZK is the approach that gets the most, it's gotten the most mind share so far in terms of just very smart people working on it. A lot of venture dollars have gone into ZK projects, and everyone's betting on the same thing, this HTTPS moment where all the valuable on-chain transactions are no longer happening in the open, which will expand crypto's TAM. These approaches are not directly equivalent. So like this table, like many things, is wrong but useful in terms of actually like looking at different approaches. And in practice, which we can get into in a second, we expect a lot of these things to end up being complementary as opposed to competitive. So what are TEEs? Trust execution environments are a partitioned part of a chip that is hardened against access by someone who's physically in possession of the chip. These became pretty ubiquitous as computation moved off-prem. Back in the early days of technology, generally when you were doing operations, you were doing when you were like using compute, you were using a computer that you had physical possession of. It was a mainframe on a college campus or like a desktop in your home office. And as this changed, as networks evolved, and like eventually after the advent of cloud, people were doing more and more valuable transactions on hardware further and further away from them, which created demand for hardware that was hardened against access by people who could physically touch the devices. If we're going to put things that are important on AWS, we don't want like some technician at AWS to be able to download all of our data. And this is the problem that TEs, in theory, solve. There's 100 million, so we tend to focus on Intel's SGX, which the person before me, the speaker before me was talking about quite a bit. This is by far the most adopted TE standard, specifically because Intel is responsible for making quite a few CPUs. And it's pretty ubiquitous now on basically Intel's higher-end chips. So TEs are a specific subcomponent or a specific partition within a chip that is hardened against access from any other people. So TEs in crypto have a long and pretty convoluted history. The most well-known use of TEs was to actually launch a blockchain called Secret Protocol, and they were definitely in the TE apologist camp, which we can get into in a second. Switchboard, MobileCoin, Avalanche, all have done quite a bit of work with TEs. Flashbots with Suave has really been pushing TEs recently and has brought them much more into focus in terms of the research community at large. So there's broadly two camps around TEs. There's TE skeptics who are just generally critical of trusting hardware. From their perspective, the representations of hardware manufacturers are essentially a fig leaf that is used, that teams will use to essentially like offload responsibility for building secure systems. Because the people, they'll say the people using TEs are just saying, oh, we trust Intel, so therefore we can just not take responsibility for any hacks that happen. Secret had a very, very bad exploit where essentially because of how they built their system, it was set up in a way where any breach of any TE could lead to all the past transaction data being decrypted, which was a really interesting design choice in terms of they're betting the entire house on an event that had occurred multiple times before, never occurring. And this gets pointed at quite a bit in terms of why TEs are not the right path forward. TE apologists, on the other hand, tend to be people like the Secret team who basically believe that TEs are like God's gift to man in terms of being the right way to do any form of encrypted computation today. People who are falling into this camp tend to basically focus on the fact that TEs are incredibly performant. They're live now, and they'll basically, as I just did a second ago, tend to focus on the poor architecture decisions as opposed to the limitations of the tech when talking about past hacks. So a lot of what we put a lot of time thinking into where and how to use TEs, because the truth, as usual, is like somewhere in between. Like neither the skeptics nor the apologists are right. Generally, what TEs have, which things like ZK are a long way from having, is incredible latency. You can basically do your round trip time for doing a transaction in a TE is almost instantaneous, whereas with most ZK systems, it's measured in minutes. How to actually measure a ZK system is something that many people much smarter than I am have spent a lot of time thinking about. You really want to limit downside of TEs. You don't want to do things where like a lot of funds or a lot of values at risk if it gets compromised. These systems have been compromised in the past. They'll be compromised again. They'll be compromised in the future. And so the way around this isn't just basically betting that'll never happen. It's mitigation rather than prevention. TEs excel when you need global private state. If your application needs there to be information that no node in the network knows, TEs are essentially your only option. Then constructive security. A point that gets made and can't really be made enough is you can basically make any system more private by adding TEs. And so, to some extent, the question shouldn't be why, but it should be why not. So, crash course on liquidity. This is mostly just if you're not a quantitative market maker, you probably don't know some of this information. And so we thought it'd be useful to give a little bit of detail here before jumping into the next slide. In most markets, there are two sets of actors. There are liquidity takers and liquidity makers. Takers are people who just want to buy an asset for whatever reason. Makers are mostly there to essentially just make profits by like filling orders, right? So they're buying and selling at both points in time on both sides of the book. If you look at the order book, a market maker, so all those orders in most markets are actually placed by usually a quantitative market maker who is trying to run a balance book. And so if you buy from the green, they'll basically move the inventory over to the red and hope someone else does the opposite trade to get them back to even. Markets don't work without market makers. Like if you ever traded into any central limit order book system, the market makers you've been trading against a market maker. So what market makers, the amount of risk a market maker takes depends on latency because their orders are live for some amount of time. And so the amount of how rapidly they can cancel impacts how safely they can quote. If my quote has to be good for an hour versus 1 second, I have to offer a lower bid or higher ask in order to not lose money to the taker. If you look at basically how to measure markets, quicker cancellations equals tighter spreads because the bids and asks are closer, which leads to basically better price discovery and lower fees for the end users. Right now in crypto, price discovery happens in Uniswap and Binance. So Trastero, we think that order books are the perfect application for TEEs because order books require latency. Lower cancellation latency equals a better market, and your downside is very limited. Basically, if a breach does happen, all that occurs as we revert to the current status quo. So right now, all the orders and everything that's decentralized are visible. And if you simply put the order book inside a network where every node's a TEE, the only real downside is reverting to what we have today. And the latency benefits make it something that can, in theory, compete with Binance. So what's next? We think that the road towards, we think crypto's HTTPS moment is going to happen through layering and combining different approaches that we highlighted on the road to privacy. We think TEEs are the right place to start because you get performance today, and you have characteristics that allow you to do things that you otherwise can't do. But over time, people will layer in things like MPC and FHE behind TEE systems to improve the privacy assumptions. So start with latency, build towards privacy. And then if you're interested in playing with our testnet, feel free to scan this QR code. And if you want a t-shirt, find someone from our team.